Hello again, year 10. Today we are going to be carrying on our topic of quadratics. We're going to be looking at an algebraic process called completing the square. And what we will see in subsequent lessons is how you can use this process as another way of solving a quadratic equation. So let's get those brains awake with another quick activity. I have written lots of algebraic expressions down. Some of these algebraic expressions are equivalent to each other. And what I mean by that is if you multiply out the brackets, you will find the expressions are the same. So all I would like you to do is just spend a couple of minutes seeing if you can spot which ones are equivalent to each other. So pause the video here because I'm about to go through the solution. So I'll go through some of the harder ones first. If you have a bracket here with a squared, you really need to multiply this out using FOIL. If not, you're likely to get it wrong and you probably thought, oh, maybe this isn't one that matches up. If you multiply this out with FOIL and collect terms, you'll get an a squared. You'll get an AB from the outers, you'll get an AB from the inners, so you'll end up with two ABs, and you'll get a B squared. So that one there matches with this one here. Similarly, if you did the one with a negative, you'll find it's very, very similar, except you get negative 2 ABs. So that one matches with that one. For the single bracket problems, you just have to multiply what's inside the bracket by what's outside. So we'd get a 2a on this one, a 2a and a 2b. So that one goes with this. On this bracket here, we would get an a times an a, which is an a squared, and a times a 2b is a 2ab. So for that one, we are looking for an a squared plus a 2ab, which is that one up there. And finally, let's just check that this does match. 2b times a would be 2ab, and a times 3a would be 3a squared, but we're subtracting it. So yes, those two also match. Now, one of the reasons why we've started with this as a little activity is because this process of completing the square is how we write a quadratic equation in an equivalent way. So I hope you've been able to print out the sheet for today's lesson, but don't panic if you have been unable. Our title is Quadratics 9, and our objective for today is rewrite a quadratic by completing the square. Now, completing the square is just a fancy name given to writing the quadratic in a different way. It's called completing the square because the way that your algebra will look when it's finished involves a squared. So I've just said another approach to solving a quadratic is to rewrite it in the form x plus p all squared plus q. The p and the q are just numbers that we need to determine. And we will see next week in our next lesson how we will then use this idea to solve a quadratic equation using inverses. Now, we are going to use a little bit of a trick today to help us, and I want you to understand where this comes from. So what I'm going to do first is just expand that quadratic x plus p squared and just see what that part is equivalent to before we go on to explain something. So if I multiply out x plus p all squared using FOIL, this is what we will get. I will get from my first x squared. I will get from my outers plus px. I will get from my inners plus px. And I will get from my lasts p times p, which is p squared. If I just tidy that up, I get x squared plus, well, I can put a px and a px together to get 2px x's. And I'll get a p squared on the end. Okay? Now, we're used to seeing quadratics in the form x squared. You might have a number here, but we're not going to see that today. Plus so many x's plus a number. And what I would like you to just quickly see here is that 2p is the same as this value, the coefficient of x. So 2p is the same as the coefficient of x. So if I'm starting with a quadratic that is in this form, and I'm trying to rewrite it back as x plus p squared, well, I already know the number that p is going to be. P is going to be half of this number here. And that is super important in the process of completing the square. So we have just spotted by comparing these expressions that p, the number that's going to go in our bracket today, is always half the coefficient of x. So how many x you've got, and you will halve that. I think then the easiest way to work out q is by doing a comparison of what you already have and what you need it to be. And that will make sense in a minute as we work through some examples. So, let's start with this first example of x squared plus 8x plus 20. And we're going to try and write it back in this form, x plus p squared plus q, which is called completing the square. Now, if you have followed me so far, you will already know what the value of p must be. We look here and we use half of that value. So we have already worked out what p is. How are we going to work out q? Well, what I'm going to do is I'm going to see what I already have by just doing a little extra calculation over here. I've written down that this is x plus 4 squared. And if I multiply this out with FOIL, you will see that I get x squared plus 8x plus 16. So at the moment, it isn't x squared plus 8x plus 20. It is x squared plus 8x plus 16. So what extra do I need to make it plus 20? Well, if it's 16, I need an additional 4. So I'm going to add 4. And that is that expression finished. Let's look at some more examples. So in my next example, I have x squared plus 6x take away 3. So first of all, I'm going to decide what needs to go into my bracket. It's always going to be x. And then remember, I am using half of the coefficient of x. Well, it's plus 6, so I need half of that, which is plus 3. Now I'm going to explore what x plus 3 squared is the same as. So I'm just going to check what I've already got with FOIL. I've got x squared plus 3x plus 3x plus 9. So I've got x squared plus 6x plus 9. So you can see, I've got the x squared. I've got the plus 6x, but I don't have the minus 3. I currently have 9. How can I get back to negative 3? Well, 9 subtract 12 would leave me minus 3. So the part on the end that I need this time is subtract 12. Let's look at the next one. So at the front of my bracket, I will have x. And inside my bracket, I need half of the coefficient of x. Well, the coefficient of x in this one is -2. So I need -1. And again, I'm going to explore what I've already got. Now, sometimes some students don't do this. Okay? I would always recommend doing it. It's very easy to make a mistake with this final value. So be thorough and multiply it out, see what you've got. I've got x squared minus x, and -1 times -1, be careful, is +1. So this is currently equivalent to -x squared, take 2x, plus 1. Okay, so the first two bits are right, but I have +1, not take away 9. So how do I go all the way and turn that 1 into -9? I need to knock a further 10 off. Third example. My coefficient of x is 12. I need half of that. That is 6. What is x plus 6 all squared? It is x squared plus 6x plus 6x plus 36. So it is x squared plus 12x plus 36. I need 30. I have 36. Subtract 6. Is it always going to be a takeaway here? Not always. Okay, let's have a look at the final example, because some of you might have been thinking about this. If the coefficient of x is odd, it's going to make life a little bit trickier. So, I need half of -5. I personally would do this using fractions. I know one or two of you will be less confident using fractions, so I'm going to do this in decimals instead. So it would be x minus 2.5. Let's see what that is the same as. One or two of you might need a calculator for part of this. Well, that is x squared minus 2.5x minus 2.5x. And minus 2.5 times minus 2.5 is plus 6.25. So I've got x squared minus 5x. That bit's good. But I've got plus 6.25. And I need to get all the way up to 10. So I need to add a bit extra this time. And it is 3.75. If I was doing this question, I probably would write both of these answers either as a mixed number or even as top-heavy improper fractions. So I'm not going to give you many questions to try. I think 9 is enough to just see if we get the right idea today. So you'll need to go back to my instructions, access the PowerPoint to view these questions, or just pause the video here and view the questions from here. Do remember in the last 5 minutes to check your answers. Make it clear by using a different coloured pen. And if you've got something wrong, then make sure you correct it. If you don't know why you've got it wrong, you should be asking questions, please. As with any lesson, if there's any problems at all, remember you can ask in the Ask the Teacher channel.